Hello there. Welcome to section 2 of Unit 4. And for this section, we'll be dealing with electromagnetic waves. Let's look at the objectives of section 2. We have 5 objectives here, and the first one is for us to be able to look at electromagnetic waves, wave spectrum, visible light, frequency of light rays, and radio and microwaves. I believe we do all use microwave in our kitchen, watch television in the house, and also listen to radio. They are all examples of electromagnetic waves. Other examples are the visible light, the infrared, and the X-rays that we use in the hospitals. But the difference between them is their frequency, the wavelength, and their energy that they all carry. Electromagnetic waves are produced by the motion of electrically charged particles. An example is what I've stated earlier. You should not be surprised to know that everything emits electromagnetic waves according to its temperature. Even your own body emits electromagnetic radiation according to your temperature. That is why we are able to use that to construct the infrared thermometers or the thermometers gun that we use in the hospital, which was mostly used during the COVID time. Note that hotter objects emit more energy than cooler objects, and every wavelength, and that the hotter objects emit most of their energies at shorter wavelength than the cooler objects. As stated earlier, the electromagnetic radiation can be expressed in terms of energy, wavelength, or frequency, and is presented on the electromagnetic spectrum. As the energy increases, it is expected that the frequency too should also increase. But when the energy increases, the wavelength reduces. And I say this from our previous formula that we know, where we know that E to be equals to H times F, where F is our what? Is our frequency. So because it's directly proportional, we expect that anytime E increases, right, the frequency to also what? Increase. The H here is a constant, that's Planck's constant. The F here can also be represented as H times C over our wavelength. So that anytime the E increases, we expect that the wavelength here should also reduces. Or anytime the frequency increases, we expect that the wavelength here should also reduces. So anytime, let's use an example like the visible spectrum, where we start from blue here and we end at red here. Or say we start from violet and we end at red here. The violet or the blue has a very short wavelength but has a very high energy or high frequency. But when you look at the red here, we have a very long wavelength but it has a very low energy or low frequency. You should be able to explain this and also be able to compare using frequency, energy, and wavelength.